All right, let's take a look at how we can derive the distance formula from, it actually ties in with the Pythagorean theorem, and that's how we got our distance formula. So if you were asked to find the distance between P and Q, because it's kind of on a slant right there, you just can't count units on a coordinate plane. You can count units if you're going horizontally, and you can count units if you're going vertically. So if we go horizontal and then vertical, we actually can create a right triangle right here. This ties in with your Pythagorean theorem. Let me just remind you what that is. A squared plus b squared equals c squared, where a, b, and c are three sides of a right triangle. C has to be the hypotenuse. So the distance we're finding is the hypotenuse of this triangle. There's our side A, and there's our side B. The A and B could be switched. So if we plug this into our Pythagorean theorem, to find the distance of this, like how long is this side of our triangle, we would just subtract. What's your x2 minus your x1? And the reason why they have it in absolute value bars is because we want that distance to be positive. So I'm taking our side A, I'm plugging it in right here, and then that's going to get squared. Now I'm going to plug in our side B, which side B is finding out what's the length of this side. So you take your y2 minus your y1. That's how you could figure out how long that is. And we subtract y2 minus y1 squared. So here's our a squared plus our b squared equals c squared, that third side. Okay, so to get our side C, which is our distance, right now we have a c squared. All we have to do is square root both sides. So we're going to square root the right side. That leaves us with side C, or our distance, because they also labeled it with a D. And then we're going to square root this side. And you can kind of see how this is looking like our distance formula. The square root of, now these absolute value bars, if we didn't have the squared, those would be really important because we want that positive distance for the length of your side of your triangle. But the squared takes care of that. If you are squaring a positive number, it stays positive. If you're squaring a negative number, it turns positive. So I'm going to go ahead and switch those to parentheses because the squaring is going to give us a positive length right here. And then plus y2 minus y1 squared. There's that square root, and you can see that our distance is equal to this, which is our distance formula, and it came from our Pythagorean theorem.